So we are going to factor using multiple methods of factoring for these 4 problems. These are 4 fairly common problems that require factoring multiple times. So these are a good representation of what you're going to be expected to do. Before we get started on actually factoring, Sam, I need you to tell me, what order do I look for things when I factor? What's the first thing I look for, sir? Oh, we should know this by the on top of our...
Monomial.
Okay, I'm going to write it down. Hold on a second. So the first thing is a greatest common monomial.
Difference of squares.
Difference of squares. And you realize for your test you will not have your folder available. Okay.
Square binomial. And binomial pair factors.
Ah, that should not be an and. Binomial pair of factors. And number 5?
Factoring by grouping.
Okay. So we are going to go through all of these problems going through the checklist. It is a dead giveaway that you may have to factor multiple times when after you factor the first time, you still have something squared. So that's the clue to you that I may have to factor this again if you end up with a something squared. All right, so let's look at the first problem. We have d to the third minus 2d squared minus 24d. What's the first thing I look for? Nolan?
Greatest common monomial.
Is there a greatest common monomial in this problem? Okay, what is the greatest common monomial? D. So I'm going to factor out a d from all of these terms. Now remember, when you factor out a greatest common monomial, it does not disappear. It gets chucked on the outside of the problem, like Dino. D to the third divided by d is?
D to the second.
D squared. Negative 2d, okay. And then finally, negative 24d divided by d is? Okay. I see that I am left with a trinomial that has a term that is squared. That tells me that I have to think about factoring. So I've already done looked for the greatest common monomial. So then, is that trinomial a difference of squares?
No.
How do you know it is not a difference of squares? Trevor?
Because negative 24.
Negative 24 is not a square number. I would totally agree with that. Sorry about that. Okay. So we are stuck with looking, since negative 24 is not a perfect square, we are stuck looking for a binomial pair of factors. So we can either make the rectangles or we can make a factor sum table. Which would you rather do?
Square.
All right, let's do a factor sum table. So we have a factor, or so here we go. So we have a small square here. I'm going to break it apart. What is the area of this bottom left piece going to be in this problem, Betsy?
D squared.
It's going to be d squared. What is going to be the area of this right here? Negative 24. Okay, so we're looking for 2 numbers that multiplied together equal negative 24 and added together equal negative 2. What might they be? Brandon? 4 and negative 6. So the length of this side length is d. So we have the length from here to here is 4. The length from here to here is going to be d, because that's the only way we can get the d squared. The length from here to here will be negative 6. So negative 6 times d is negative 6d. 4 times d gives an area of this piece here as 4d. Add these two together, negative 6 plus 4, negative 2. So we have a winner. So the correct binomial pair for this trinomial is what? Allie?
D equals negative 6.
No, not exactly. Not exactly. So we're looking for a binomial pair of factors. So there's no equals in this. There's no equals in this.
And then minus 6? Yeah,
D minus 6.
And then D plus 4.
There you go. But wait a second. We have not done anything with this. It does not disappear. So the D is going to hang out on the outside. Are there any questions for our first problem? That is our answer. So we have D times the quantity D minus 6 times the quantity D plus 4. And that is your final answer. We factor it twice. You will find that the most common form of factoring is when you have to do it in multiple times, is there's going to be a greatest common monomial, and then you'll probably be left with a trinomial that can be factored with a factor sum table or the rectangle. So that will probably be the most common. Yes?
So does it matter that negative 6 and 4 don't equal negative 2D? You just ignore the D?
Well, here's what I did. I said negative 6D plus 4D. I just dropped it when I said it verbally. So you get, it's okay, you get negative 2D. I'm prone to take shortcuts too. All right, question B. Question B. Have our checklist still. So what is the first thing that we look for in question B? Joe. Greatest common monomial. Does this have a greatest common monomial? Yeah, it does. What goes in F? I'm hoping that after this video, your grades will not be D's and F's, right? All right. Yes, that's right. I'll be performing here all year. It wasn't really that funny. All right. So, what goes into both terms? F. It's not a difference of squares yet because this this term right here, F, is not a perfect square. So, like we said before, when you factor out a greatest common monomial, it does not disappear. It goes on the outside of the binomial. So we have f squared, because f to the third divided by f is f squared, minus, what is 16fh squared divided by f?
16 squared.
Okay. So we see that we have some squared terms. That is a signal to you that you have to look for more ways of factoring. So we've already factored out the greatest common monomial. So what's the next thing that I look for, Trevor Knopf?
Difference of squares.
Difference of squares. Is this a difference of squares?
Yes.
Why do you know it is a difference of squares? Trevor.
16 is a perfect square.
16 is a perfect square. What else is a perfect square? H squared is a perfect square. What else?
F squared.
Okay, so it's definitely a difference of squares. So when you have a difference of squares, what do you know is going to be in the answer, other than a pair of binomial, a pair of parentheses? Marina. A plus and a minus. Okay, so what's going to be this first term right here? What is going to be the first term right here? Oscar, you're looking way too comfortable, so why don't you tell me what goes here and here? F, because f times f is f squared. All right, what goes here and here? Allie? 4h.
Oh, so you just...
So in other words, we're taking the square root of both these terms. And now, is this our final answer?
No.
What am I forgetting? What am I forgetting, Brittany? I'm forgetting the f. Okay, so our final answer is f times the quantity f. I'm glad that you find this so exciting, folks. Times the quantity f minus 4h. All right. Now, we can factor it more if and only if we have something squared. Do we have any squared terms?
No. Yes. 4.
4 is a perfect square. However, is H a perfect square? No. Is F a perfect square? No. So we are done.
Wait, don't you want to write like a little?
Squared for difference of squares?
Yes.
No, you don't.
Okay. So moving on to the next one. By the way, in question A, we had a greatest common monomial and then a binomial pair of factors. In the second one, we had greatest common monomial and a difference of squares. So you'll see a fairly common pattern in what the possibilities are. All right, this question C is another very common way of requiring you to factor several times. So what's the first thing that we look for in question C? Is there a greatest common monomial? No, there's no greatest common monomial. So what's the second thing that we look for? What is the second thing that we look for? Peter? Is this a difference of squares?
Yes.
Yes. T to the fourth is a perfect square. 256 is a perfect square. And we are taking a difference of the two perfect squares. Therefore, it is a difference of squares. Could someone please tell me what will be in all answers for a difference of squares? This is very common theme here. Olivia?
Plus and minus.
So there'll be a plus and a minus. What else will there be in all differences of squares? Nolan? 2 pairs of parentheses. Okay, so we are going to take the square root of both terms. What is the square root of t to the fourth? Oh, that's t to the second. What is the square root of 256? Jenna?
16.
It is 16. So I have successfully factored. Oh, awesome. So I've successfully factored the difference of squares the first time. So we ask ourselves, do we have a squared term
Yes.
here?
Yes.
We do?
Yeah.
Yeah, we do. Okay. So we have t squared plus 16. Is 16 a perfect square?
No.
Is t squared plus 16 a difference of squares?
No.
No, why not?
It's a plus.
It's an addition sign. It's a sum of squares. It's a sum. You can't factor it.
Is this square by
It can't. A square binomial will be a trinomial. So t squared plus 16 is not factorable.
Why not?
Because it is an addition of 16. So if you factored it, you would you can't factor it because if you multiply two binomials together, you'll end up with a trinomial, get a linear term. But in this case, t squared plus 16 does not have a linear term because it doesn't cancel out. So is t squared minus 16 factorable? Yeah? Why is it factorable?
Because t squared is a square and 16 is a perfect square and it's subtraction.
Oh, so this is a perfect square, this is a perfect square, and we are looking at a difference of perfect squares. Okay, so what's going to happen with this t squared plus 16?
Stays the same.
It stays the same. It just gets dropped down to the next line. When we're factoring this as a difference of squares, what will be in the answer? By the way, there's a hint, Sean. It will be in all difference of squares answers. So, sorry, McLovin. So, what will go here? Sean? Sean? What goes in all answers for differences of squares?
Oh, minus.
There will be a subtraction. What else?
Plus.
There will be a plus. What else, McLovin?
Parentheses.
2 pairs.
2 pairs of parentheses. All right, Sean? What is the square root of t squared?
T.
So that is the first piece of both binomials. What's the next piece?
4.
4, because 4 is the square root of 16. So we now have our final answer. So in the first two problems, we had a greatest common monomial followed by either a trinomial that was factorable or a binomial that was a difference of squares. The other common type of multiple factoring situations is when you have two differences of squares. Okay? All right. The last problem we are going to talk about looks a little bit funky. It looks a little bit funky, but it's really not too bad. So we have two terms. We have a term of 4 times the quantity a minus 2 squared. And then we have our second term, which is negative 36. Do these two terms share anything?
No.
Joe? Oh my goodness, it is a difference of squares, you're right. But wait a second. What is the first thing that we look for in our checklist? We have to look for a greatest common monomial first. So what goes into both of these terms? Olivia? 4. So we have a 4 on the outside. When we divide this by 4, we're just going to get a minus 2 squared minus, what's 36 divided by 4?
9.
9. All right. So we've factored out the greatest common monomial. Now let's look at our checklist. Do we have a difference of squares?
Yes.
Yes, we do, because the quantity a minus 2 squared is a perfect square. 9 is a perfect square. And we are taking a difference. We're taking a difference right there with the subtraction. So, does the 4 disappear in our answer? No. What will occur in all differences of squares?
Plus minus.
McLovin?
Plus and minus.
All right. We'll have a plus and a minus. What else will we have, sir?
Parentheses.
We'll have a pair of parentheses, okay. In this case, I'm going to use brackets, but you'll remember that brackets are the same as parentheses.
Why are you using brackets in that case?
I will explain when we get to it. What is the square root of a minus 2 squared? It's the quantity a minus 2. So that goes in both. What is the square root of 9?
3.
Excellent. Woohoo. All right. And now here is the last piece to this puzzle. Do we have any common terms that can be combined inside this this trinomial? 2 and 3. Negative 2 and 3. What is negative 2 plus 3?
1.
It's positive 1. So we still have the 4 on the outside. And we end up with a plus 1. Do we have any common terms here that can be combined?
Negative 3.
Joe? Negative 2 plus negative 3 is? Sir? Negative 5. So we now have our final answer. So that one is probably the funkiest one that you will see.